So I am Sunanda. Now this video mainly deals with Python programming bitwise operators. So of all the operators we have, so these operators mainly help us to perform the operations on the bits, not the values, right? So whatever the numbers we have, the numbers will be converted into the bits, and on those bits we will be performing these bitwise operators. Python will provide mainly 6 bitwise operators. One is bitwise AND, which will be represented as ampersand symbol, bitwise OR, and bitwise XOR, that is a cap symbol. Right shift, so this indicates two less than symbols. So this mainly specifies the direction, the right side direction. So this is the right shift, and these are the two greater than symbols which will show the left direction. So this is a left shift. And next we have the bitwise NOT, which we use a tilde symbol, right? So when you have the two bits, so let us consider the value x and the y or the two bits. So the bit is nothing but the 0 or 1. So bit is considered as either 0 or 1. So I am considering two bits x and y having the values varying from 0 and 1. So if x is having the 0 and y is having the value 0, so if I perform AND operation on the bits x and y, then the output will be the 0. If the x value is 0 and the y bit is 1, then x and y is 0. If I have the x value as 1 and y bit as 0, the value will be the 0. If the value of x, if the x bit is 1 and y bit is 1, then the x and y is 1. So here when we are performing the bitwise AND. If the both the bits are 1, then the output will be the 1, otherwise 0. So whenever you are performing AND operation bitwise AND on the two bits, if the two bit values are equal to the 1, then the output of AND operation will be the 1, otherwise it is 0. Right? So whenever you are considering the 1 and 3, so here first 1 will be converted into the binary format and 3 is converted into the binary format. So how you can convert some value into the binary format is, I have the value as 1, so what I need to do, I have to divide it by the 2. So now what I will be getting the remainder. So if you divide the 1 by 2, so the output is what? 0, 0, 1, right? So 0, 0, 1. So now when you take the value of 3, so if you divide it by 2, 1's 1. So you will be considering it as what? 1, 1, 0. 2 power of 0, 2 power of 1, 2 square. So when you again multiply it like 0 into 2 square plus 0 into 2 power of 1 plus 1 into 2 power of 0. So 0 plus 0 plus 1. What you got is 1. When you consider this as 0 into 2 power of 2 plus 1 into 2 power of 1 plus 1 into 2 power of 0. Here what I got? 2 square plus 0 plus 2 square is 0, plus 1 into 2 power of 1 is 2, 1 into 2 power of 0 is 1, that means 3 I got. So I have the two bits here, this is a 1 and this is a third. So here if I consider it as x and if I consider it as y, 0, 0, 1, 0, 1, 1. Now I am performing the AND operation, bitwise AND. So 0, 0. So x ampersand, that means x bitwise and y, that means 1 bitwise and 3. So what I get, these two are zeros. First bit of 1, say first bit of 3 will be performed with the AND operation. Now I got the 0. First bit of 1 and first bit of second bit of 1 and second bit of 3. So what I got the output as 0. Next first bit third bit of 1 and third bit of 3. So this is 1 and 1. What I will be getting the output as 1. So this is the output which I got. If you 0 0 1, so 0 0 1 is 2 power of 2, 2 square, sorry, 2 power of 1 and 2 power of 0. So the output is 1. If I consider 5 and 4, so what is the binary format of 5? As I am considering as a binary, so I am dividing it by the 2. So 2s are 4, 1. So 2 1s are 2, so 1. So 5, what is the value of 5 is 1 0 1, and for the 4 is 2 2s are 4, 2 1s are, excuse me. So what I got 1 0 0, right? So 5 and 4, 5 is 1 0 1, 4 is 1 0 0. The first bit of 5 will be AND with first bit of 4. What I got is 1. 1 and 1 is 1. 0 and 0 is 0. 1 and 0 is 0. So 1 0 0. 2 power of 0, 2 power of 1, 2 square. What is 2 square is 4. So the output is 4. Like that it will be calculated. So whenever you are giving the input, you will be giving the values itself. Normal, decimal, integer values you will be giving. Internally, while performing the bitwise operators, the values will be converted into the bits, and the bitwise and bitwise, or whatever the bitwise operators we have, will be performed. It will just give the output for us. So this is how it will. So conversion will be done like this. So bitwise bit, the operation will be performed. So we are calling it as bitwise operators. And here I am considering it input number 1, enter number, a second number. So just reading 1 and 3, what is the output I got? And if I take 5 6, so what is the output I got? 4, right? And bitwise OR, it is the opposite to that of bitwise AND. If either of the bit is 1, it will give the output as 1. Otherwise it will give either and both the bits are 1s, it will give the output as 1. Otherwise it will give the output as 0. If either of the bit is 1 and both the bits are 1, it will give the output as 1. So either, so here the first bit is 0, second bit is 1, so the X or Y is 1. So first bit is 1, second bit is 0, X or Y is 1. First bit is 1, second bit is 1, it gives the output as 1. Otherwise 0. If the two bits are 0, it will give the output as 0. Otherwise what? It is giving the output as 1. If the two bits are 0, it is giving the output 0. Otherwise what? 1. Right? So if I consider 3 5, what is the value of 3 5? So 3 is 0 1 1 and what? 1 0 1, right? 1 0 1. Now these two bits are and 1 OR operation is performed. Now these two bits are operation, these two bits are operation. So what is this value? 2 power of 0, 2 power of 1, 2 power of 2. 4 plus 2 plus 1, what I got? 7. So it will give the output as 7, like that, right? So this is how the bitwise OR operation is performed. If either bits is 1 and both the bits is 1, then the output will be 1, otherwise 0. Or you can even specify it as, if the both the bits are 0, it will give the output 0, otherwise 1, right? And this is an example, same, but in terms of the program I have considered. So just you have to mention this R symbol in between two numbers. So internally the numbers will be converted into binary format, and it will perform the OR operation and it will give the output to you, right? So coming to the cap operation, if both the bits are same, it will give the output as 0, otherwise 1. If both the bits are same, that means here the first bit is 0, second bit is 0, it is output is 0. The first bit is 0, for 1, second bit is also 1, so the output is 0. Otherwise what? Otherwise 1, right? If both the bits are same, it will give the output as 0, otherwise it will give the output as 1. So 3 cap 5. So 3 is 0 1 1, 5 is 1 0 1. If the both the bits are same, it will give output as 0. If the both the bits are different, 1, 1, 1, 0, 2 power of 0, 2 power of 1, 2 square. 4 plus 2 is what? 6. So the output is 6. Right? So this is how same 0, same 0. Otherwise what? 1. Right? Same program, but here the numbers will be converted into the binary format. So coming to the right shift, so here we have a shifting of the bit places. So if I consider this is a represent 8, so let me take the 8 value. So 8 in the normal binary format, how you can represent 8 is, so whenever you are considering the shifting, or whenever you are considering the binary operation, so instead of taking the 4 bits, you have to consider 8 bits, because 8 bits equal to what? 1 byte. So in the computer language, everything will be in terms of the bits and the bytes. So as the length of the 8 bits is 1 byte, so whenever you are considering the binary format, or in terms of the bits, you have to represent as 8-bit length. Okay, so 8 to 4 0, to 2 0, to 1 0. So what is the value of 8? 1 0 0. Now what I have mentioned, what is the shift it is? So the direction is towards the right, so this is the right shift. So 1 0 0 0, 8 bits is here, you can prefix it with the zeros. That's it. So when you again calculate the value in terms of the 2 power of 0, 2 power of 1, 2 square, 2 cube. So what is 2 cube? 8 plus 0 plus 0 plus 0, that is 0. So 0 into anything is 0, so that's why you are prefixing it with the 0. So what I have mentioned, 2 times right shift. So the first from starting from the left to the right, the bit place should be changed to one place to the right. It has to be shifted one place to the right. So this will be shifted to this place, this will be shifted to this place, and this to this, this to this, and this to this, this to this position, this to this position, and this to this position. So here this 0, this is a 8, if I take 8 7 6 5 4 3 2 1, so 8th position 0 will be shifted to the 7th position, 7th position to the 6th position, 6th position 0 to the 5th position, 5th position 0 to the 4th position, 4th position 1 to the 3rd position, 3rd position 0 to the 2nd position, 2nd position 0 to the 1st position, and 1st position it has been shifted. Now if the 1st position has been we have moved to the 1st position, there are no more places, so to the 8th position what it goes is, it just fill it with the 0. Now what is the value after the first shift is 2 square, 2 power of 1, 2 power of 0, that means 4 I got. Now again I need to shift one position. As I mentioned here, this is a shift count, and this is a value you have to perform the shift. Okay, so as I mentioned, 2 bits has to be shifted. So now the 8th position 0 will be again starting from the 8th position, you have to move. So 8th position 0 to the 7th position, 7th position 0 to 6th, 6th to the 5th, 5th to the 4th, 4th to the 3rd position, 3rd position to the 1st position, 1st position to the, now I will be getting the 0 at the 8th position. So when you calculate the value of it, what is it is 2. So this is how you got the value 2. So we have to move the positions of the bits to the right side. So how many places you have to move? 2 places. That is what this 2 indicates, right? So if I take the value, if you want to know whether you have shifted correctly or not, then what you have to do is, you can use this formula, y equal to n by 2s, where the y indicates the value which you n indicates the value which you want to shift, and s indicates the count, how many times you want to shift. So as I have taken n, say for example 8 right shift 2, so what is the this s, this is the value of n. So now when I calculate the value of 8 by 2s, that means 2 power of 2, that means 8 by 4, what I got 2. So y value is 2, that means the value I got here is equal to the value I got here. So I can say that the shifting I have performed is okay, correct, right? So this is example program which will illustrate the right shifting. So just you can mention like this, you have to give the value of n and the value of s, it will shift internally and it will give the output for you. Coming to the left shift, which is opposite to that of the right shift. So as the arrows indicates towards the left, directed towards left, it is a left shift. So here we will be considering the same what we have considered for the right shift, the same we will be performing here also. So let us take the same thing, 8 right, left shift 2. So for the 8, 0 0 0 0 1 0 0 0. Now from starting from the 8 7 6 5 4 3 2 1. Now from the first bit we have to move to the left side. The first bit towards the left side it has to move. Each and every bit has to shift towards the left side, one position. Okay, so 0 will be shifted to the second position, this second 0 to the third position, third 0 to the fourth position, fourth position, and this fourth 1 will be shifted to the fifth position, and this fifth 0 will be shifted to the sixth position, sixth 0 will be shifted to the seventh position, seventh 0 to the eighth. Now at the first place we will be prefixing with the 0. They you will be suffixing here, not prefixing, you are just suffixing it with the 0. Now as I mentioned the 2 here, 2 times it has to get shifted. Now this first 0 will be shifted to the second position, and second 0 to the third position, third 0 to the fourth position, fourth 0 to the fifth position, fifth 0 to the sixth position, sixth 0 to the seventh position, seventh 0 to the eighth position. Now this will be the 0. 2 power of 0, 2 power of 1, 2 square, 2 cube, 2 power of 4, 2 power of 5. What is the value of 2 power of 5? 32. Now the 32 will be the output, right? Like this you will be performing the left shift, right? So here this is another notation where you can check whether you have performed the correct left shift or not. For the right shift you will be taking n by 2 power of s. For the this is for the right shift, and for the left shift you will be taking n into 2 power of s. So here 8 will be 2 and s will be again number of shifts, how many you have performed? 2. So 8 into 4, what you got? The output is 32. So is this the same output you get? Yes, 32. That's why you can even check like this. Okay, so this is an example program for left shift operator. Thank you.